Thanks, Greg. Good morning, everyone. I'm happy to be here to talk about the 10-year response of irregular shelterwood in Quebec. This is in the same research program that Patricia talked. So the outline of my presentation is the context of irregular shelterwood in northern hardwoods. And we will talk about the Duchesne experience in northern hardwoods. And we'll talk about the methods and the 10 years result. And we're going to have a summary conclusion. So the context. I think this context is applicable to all the northern hardwoods forests in North America, of at least maybe 80% of this forest. Selective cuttings in northern hardwoods have impoverished stands in terms of quality, composition, and structure. And also, the largest trees are mostly harvested. Most valuable species have been also harvested. Regeneration of valuable species like sugar maple and yellow birch has decreased, and beech regeneration has increased. This is a sad story, but this is the reality. So, and after that, herbivory with white-tailed deer browse valuable species, and it has increased in Quebec in the last decades. And after that, the beech bark disease appeared in Quebec, and it is covered most of the range of American beech now. So we have big challenges, and we need to adapt silviculture of northern hardwoods. The selection system is not well adapted to irregular and low quality stands, and in most favor regeneration of shade-tolerant species, like American beech. The regular shelterwood is not adapted to irregular stands that result from selective cuttings, because we often have many valuable small and medium-sized trees. And the regeneration conditions need to be improved to reduce competition and favor establishment of desired species. And the complexity and diversity are recognized to promote resilience to global change. So we need to adapt also for climate change. The irregular shelterwood system, Patricia talked about that, but just want to do it with natural disturbances. To compare to natural disturbances, we could say that irregular shelterwood fell between the light and severe. So it is a moderate, it emulates moderate natural disturbances like windstorms and outbreaks. It offers more flexibility than traditional silvicultural systems like selection and regular shelterwood. And also helps to maintain complex structure and create favorable conditions for diversity of species. Okay, and Patricia talked about that. There we have 3 variants. So I'm going to continue not to repeat that in my presentation. But specifically for northern hardwoods, we aim to regenerate new cohorts while maintaining a continuous cover. This is the continuous cover irregular shelterwood system, and favors species diversity, especially mid-tolerant species like yellow birch. And it is an alternative to the single tree selection. And the difference that we have more area in groups and smaller residual basal area than the selection system. It provides also more flexibility to harvest more unhealthy and or at-risk trees. For example, trees infected, beech infected by the beech bark disease. We can also use the continuous cover to convert to a single tree selection. So from a degraded stands to conduct the stands to the single tree selection could be possible if you want. The extended, particularly in the northern hardwoods, we aim to maintain a partial cover for at least 25 years. And the final cut is optional. So it is an alternative to the irregular shelterwood and converts even age stands to 2H. Could also be used to rehabilitate low quality stands. And it is also it has a greater aspect for aesthetics and social acceptability, and could maintain some stand attributes like stands or big trees. So the typical scenario is seed cutting at year 0, a secondary cutting at year 5 or 10, and a final cut maybe after 25 years or more. We experienced these systems in the northern hardwoods in Quebec. The main objective was to compare the outcomes of hybrid single tree and group selection, which was the most prescribed at the northern hardwoods at the beginning of the study, and compare it to the continuous cover and extended variants regarding stand structure, regeneration, and stand growth and yield. So the Duchesne study is a case study to show the experimentation of those variants. It was established in 2009 in a sugar maple, yellow birch, and beech stands, which has an history of diameter limit cutting, and the pre-harvest acceptable growing stock was about 45%. And the soils in this study are poor-based Cascan soils, so on the Canadian shields of granitic bedrock, so poor for sugar maple. And the beech bark disease is there since 2012, and the deer population expansion over the last two decades. So this is another challenge that we have. The initial stand composition was very different between the upper canopy and the sapling layer. So in the upper canopy, yellow birch dominates the stands with 38%, sugar maple 34%, beech 23%, and other species 5%. But in the sapling layer, 73% was composed of beech. So this is a big challenge to regenerate those stands. Sugar maples account for only 17%, and yellow birch only 4%. So the experimental design is 4 blocks with 5 treatments. The treatments were randomly assigned to experimental unit. We have a control, a single tree selection with some groups, and 2 different continuous cover irregular shelterwood, and also an extended irregular shelterwood treatment. Experimental unit were about 110 meters per, a little bit higher than 1 hectare, and we put 36 regeneration plots on each experimental unit. We also added deer exclosure. We have 12 deer exclosure, 10 meters by 10 meters, 6 in the continuous cover irregular shelterwood, and 6 in the extended irregular shelterwood. So you have here this one. Okay. So we have an overview of the treatment. The control stands with a lot of beech saplings. Continuous cover, we have here an example of gaps that was created, and also we have the extended irregular shelterwood. On the continuous cover, we control the beech saplings in gaps, and in the extended irregular shelterwood variant, we control beech on the whole area, on the whole understory. The harvest priority was marking mostly non-vigorous trees of all species, so unacceptable growing stock, with an objective of reducing beech because of course, of the beech bark disease. And also, we want to create sufficient light to regenerate mid-tolerant species. This is an example of one block. We have, I tried to show you the pattern of the treatment. The red portion are the gaps created in each treatment. So for the selection cutting, we have 15% of gap area. For the two other continuous cover, we have 20 and 27% of gaps. And for the extended, this is a 50% forest cover. You can see the gradient here from selection, continuous cover, and extended, and the control here. So the red part are the gaps or the opening of the stand, so it is quite visible on this lighter and superposed photo images here. Equipment used was a single grip harvester and a forwarder. And we have to use a skitter blade for scarification, and we use brush saw for beech control. This is a cut-to-length logging system with scarification and beech control. So expected long-term outcomes and scenarios, we did simulation at the beginning of the study. So for the control, we expected a relatively stable growth. It was simulation done without beech bark disease, because when we started, this beech bark disease wasn't there. For the selection system, we expected a 25 years cutting cycle, and after that, continuing 20-year cutting cycle. And for the continuous cover variants, so this one here, we can see that the first cutting cycle would be 30 years and expected 20 years after that. And for the 14 square meters residual basal area, we expected 30 to 35 years at the first cutting cycle here, and after that, 20-year cutting cycle. And the extended is another big difference. The first seed cutting, and we expected to cut it for the secondary entry after 10 years, and after that, the first inning is expected about 60 years from the first entry, and maybe we're going to be able to do thinning at 20 years interval after that. And for the regeneration hypothesis, so we hope same species composition and the main cover. So the idea was not to get rid of the beech, because we know that it's impossible. And we expected the yellow birch height growth of regeneration to be higher than beech, this in highlight, so in gaps or in the extended irregular shelterwood. Sugar maple is a challenge on those sites, poor incation-based sites, and we expected a lot of American beech competition to sugar maple. So 10 years results, stand composition. So we can see that we increase yellow birch component after cutting, increase sugar maple, decrease beech component. We have a gradient of decreasing beech component. As you can see, this light blue here, we have less beech component than in the selection system. And also the acceptable growing stock was increased from 64 to 75%, depending upon treatments. diameter distribution after cutting, we can see that we kept the reverse J diameter distribution even in the extended but continuous cover variants compared to the selection system here. And of course, in the extended, we have less small trees with the objective to promote regeneration and have this is a characteristic of the extended irregular shelterwood. So for basal area growth after 10 years, you have the survival components in growth, mortality, and net growth. You can see the survival growth is a little bit less in the extended. It was expected because we remove a lot of small trees. And the in-growth is also different in the extended. We got all of the beech saplings, but I'm sure it will be a temporary situation regarding beech. Beech is in light gray here. We don't have in-growth in beech compared to other treatments because we cut all the saplings, and in the other treatment we cut the saplings all in the caps area only. So the control is invaded by beech, as you can see. So sugar maple is in black, and yellow birch is in light green, and beech is in light green. Mortality, of course, beech bark disease affect the control stands. So removing beech can have a high effect on mortality. As you can see, treatments have lower mortality than the control. I've never seen that in my whole career. This is a very high level of mortality. It's 0.7 square meters per hectare per year. So 7 meters per hectare for a 10-year period is like a partial cut effect. So for net growth, all the treatments have about the same net growth, about 0.25 to 0.30 square meters per hectare per year. And the treatment has a negative growth. And the negative growth is due mostly to beech, the mortality of beech. And the last result, I have another result after that, but here the idea was to compare the simulation done with the result we have after 10 years. So as you can see, for the control, we have less basal area after 10 years. It's about 4 meters per hectare less than expected with our models. For the selection, we have about 1 meters, but the first 5 years we have a lot of mortality of beech. That's why the curve here is different, but the slope is very identical after that. For the continuous cover 15, we have about the same as predicted, probably because we have less mortality here, and also the same for the continuous cover, but also here we have the 5-year period with high beech mortality. And for the extended, we have no growth for the first 5 years, mainly because of beech bark disease, but after that, growth is increasing. For the sapling density here, I show you the results of yellow birch, American beech, inside and outside, and other species inside and outside exposure to show you the great impact of deer. And we have also some moose browsing on this experiment. So inside exposure, we have about 8,000 to 9,000 saplings per hectare after 10 years. This is the black box here. And this is the contrary for American beech. We have a lot, about 7,000 saplings per hectares of American beech outside exclusion and about 2,000 inside. So big difference inside versus outside exclusion. And for other species, you can see that sugar maple, red maple, and non-commercial have a lower density, but this density is higher inside exclusion. So summary of results. All the cutting treatment improve percentage of acceptable growing stock, maintain an irregular structure, and create favorable conditions for the regeneration of semi-shade tolerant species. Also, the cutting treatments allow better growth than the control and strongly decrease mortality loss, promoting short-term resilience of this forest to beech bark disease. However, efforts to reduce beech regeneration and to promote other species were greatly and very greatly reduced by deer browsing. So this is a result that indicated a decreasing resilience over the long term. And to be financially feasible, this is an operational conclusion, these treatments require an industrial infrastructure to transform low quality hardwoods, at least for the first harvest, because we have a lot of unacceptable growing stock and a lot of beech to harvest. So thank you, and I want to acknowledge my collaborators of the Irregular Shelterwood program, also the field technician and the partners. So thanks for your attention. If you have questions, I hope we have, we have 4 minutes.
Your slide about the cutting intervals was very interesting to me, because that's the first time I've seen that for irregular shelterwood. I was wondering if you've seen anyone, or if you've thought about taking that a step further to, predict volume growth. And modeling in an irregular shelterwood.
We will do it in the future, because we have did an experiment of cutting all trees harvested were bucked and bring to the mills. And we have the model, Philip Averyuk work on that, and we have models to simulate the long-term growth with product. So we can have different kind of product from F1 to F3 grades, and pulp also can be simulated to. This is the next step. Thanks for your question.
Just a simple question. I saw it in both presentations. The small gaps in your irregular continuous cover, irregular shelterwood, how do you control the size? I mean, I know there's a lot of pre-planning with the research pieces, but what kind of areas are you looking at for sizes of those gaps? We're just trying to understand that ourselves here.
The results from that gaps were made by harvesting mostly non-vigorous trees, but there were not places in advance. We did that with the unacceptable growing stock and the beech component of the stands, and the size of the gaps varied between, I remember, from 500 to about 5 to the biggest one was more than 1,000 square meters in the area. So diameter of about 15 meters and to about 1.5 tree heights of diameter. This is the range that we had in this, and it was dictated by the presence of a group of unacceptable growing stock or beech clumps.
Okay.
Okay.
One more quick one.
Yeah, you have that, all the details of this experiment in Bédard and others in 2014. I put the reference, no, I could give you the reference after.
I wonder, you said that beech control was applied only where there were openings.
Yeah,
Okay.
in the continuous cover variants. And in the extended variants, it was done on the entire understory.
Okay, okay. And what was the rationale to do that? It was a financial, or you think it's because you think it won't have any effect if you do it where there's no removal?
The idea at the beginning is to have this control of beech over time in the continuous cover. So we have done it in the gaps only because we wanted to do it on a longer term. So, but with the extended, we tried to do it at the first entry. And the results show us that because of deer browsing, this is the worst situation. We have, I remember that we have about 7,000 samplings after 10 years in the extended irregular shelterwood, and at the beginning we only have about 2,000. So we did the contrary that we want to do, but this is really because of birch was browsed every year on that site. So that's not the problem of the treatment, but the problem of deer browsing, I think.